Introduction. The components of different mixture are separated by chromatography, distillation, and fractional distillation.
Objectives. At the end of this lesson, you'll be able to understand how to separate the components of a mixture by chromatography, distillation, fractional distillation. Know about separation of components of air. Discuss about purification of solids by crystallization. Classify the pure substances. Sublimation. This method is used to separate a mixture of sublimable component from a non-sublimable component by heating the mixture. If a mixture of ammonium chloride and common salt is heated, the ammonium chloride sublimes, can be cooled and solidified and collected, and salt is left behind. Chromatography. This method is used for separating colored components from a liquid by using a filter paper or blotting paper. Put a drop of ink near one end of a strip of filter paper and dip the end of the paper in a test tube containing water. Ink is a mixture of two or more colored components. The component which is more soluble in water rises faster and gets separated. Distillation. This method is used for separating a mixture of miscible liquids by boiling the mixture and cooling and condensing the vapors. Simple distillation is used for separating a mixture of two miscible liquids having sufficient difference in their boiling points. If a mixture of acetone and water is heated in a distillation apparatus, the acetone, which has a lower boiling point than water, first boils and cools and condenses and is separated from the water. Fractional distillation. It is used for separating a mixture of two or more miscible liquids whose difference in boiling points is less than 25 K. Fractional distillation is used for separating the components of petroleum, separating different gases from air, etc. Separation of components of air. Air is a mixture of gases. The components of air can be separated by fractional distillation. Air is compressed by increasing the pressure and cooled by decreasing the temperature to get liquid air. The liquid air is then allowed to warm up slowly in a fractional distillation column. Then the different components separate at different heights depending on their different boiling points. Purification of solids by crystallization. Crystallization is the process of obtaining a pure solid in the form of crystals from its solution. By crystallization, we can obtain pure copper sulfate from its solution. Dissolve about 5 grams of copper sulfate in minimum amount of water. Filter the solution to remove the impurities. Evaporate the solution in a china dish to get a saturated solution. Cover the solution with a filter paper and allow it to cool. You will see pure copper sulfate crystals are formed. Types of pure substances. Pure substances are of two types. They are elements and compounds. Element is a basic form of matter which cannot be broken down into simpler substances by chemical reactions. They are metals, nonmetals, and metalloids. Metals have luster, sonorous, malleable, ductile, good conductors of heat and electricity. Example: iron, aluminium, zinc, mercury, copper, silver, gold, etc. Non-metals do not have luster, malleability, ductile, sonorous, poor conductors of heat and electricity. For example, hydrogen, oxygen, nitrogen, iodine, carbon, sulfur, etc. Metalloids. Metalloids are elements which show some properties of metal and some properties of non-metals, like boron, silicon, germanium, etc. Compound is a substance composed of two or more elements chemically combined together in a fixed ratio. For example, water, carbon dioxide, sugar, salt, iron sulfide, etc. Did you know? Our concept of an element is due to Robert Boyle, 1627 to 1691. His definition was experimentally based. An element could not be broken down into simpler substances. This meant that all element identifications were tentative, since better techniques meant that a compound, mistakenly thought to be an element, might be shown to be an element. Another important idea at that time was the immutability of atoms. An atom of copper has always been copper and always will be copper. Nothing can change that. This idea has been shown to be wrong by the modern discoveries of radioactivity, fission and fusion. These topics overlap between physics and chemistry and will be studied later in the school year.